Hello, today I'll be going over 10.5, which is find probabilities of independent and dependent events. So let's first go over some definitions. Independent means that the occurrence has no effect on another. So the probability of independent events is probability of A and B is probability of A times probability of B. Dependent means that the occurrence has an effect on another. So the probability of A and B is equal to the probability of A times the probability of B given A. So that little line through the middle means conditional probability. So it's the probability of B given that A occurs. For numbers 1 and 2, events A and B are independent and we want to find the indicated probability. So we're going to be plugging everything into this equation here. So probability of A and B is going to equal probability of A, which is 0.3, times probability of B, which is 0.4. So that means probability of A and B is going to equal 0.3 times 0.4, which is 0.12. Number 2, it says probability of A is 0.5, probability of B is what we're looking for, and we're given that probability of A and B is 0.1. So again, we're going to plug it into the equation. So this will be 0.1 equals probability of A, which is 0.5, times probability of B, which is what we're looking for. So in order to find probability of B, we have to divide by 0.5 on both sides. And we'll get probability of B equals 0.2. Next, we're playing a game that involves spinning the wheel shown. Find the probability of spinning the given colors. So when you're spinning a wheel, all of the events are going to be independent because you could spin a blue the first time and that won't have an effect on the second time you spin it because everything will still have the same likelihood of happening. Okay, so there are 16 different pieces on here. So 16 places that it could land. And we want to spin a red, then a yellow. So there are 5 reds, and then of the 16, there are 4 yellows. So if we multiply this, we'll get 5 over 64, which is about 0.0781. So you have about a 7% of spinning a red, then a yellow. On the next one, we want to spin a green. So of the 16, there are 4 greens. Then red. Of the 16, there are 5 reds. And then a yellow. So of the 16, there are 4 yellows. And if you multiply that, you'll get 0.0195. Okay, next, events A and B are dependent. Find the indicated probability. So for number 5, probability of A is 0.3, probability of B given A is 0.6, and we want to find the probability of A and B. So we're going to plug it into the equation. Probability of A and B is going to equal 0.3 times 0.6. So probability of A and B is equal to 0.18. Number 6, we're looking for probability of A. We're given that probability of B given A is 0.4 and the probability of A and B is 0.2. So that'll be 0.2 equals probability of A times 0.4. So then to solve for probability of A, we have to divide by 0.4. So we get probability of A is 0.5. Okay, next, let n be a randomly selected integer from 1 to 20. Find the indicated probability. So that means there are 20 numbers that we can choose from, and n is 2 given that it's even. Oh, oops. Okay, sorry, hold on. We're not going to do that. Okay, so given that it's even, that means it's 2, 4, 6, 8, 10, 12, 14, 16, 18, or 20. So there are 10 numbers there. And n is 2, so only one of those 10 is 2. So we have a 1 in 10 chance because we want to pick the number 2 and we're given that it's going to be an even number, so it has to be one of those 10 that are listed. Okay, n is prime given that it has 2 digits. So there's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So those are the numbers from 1 through 20 that are 2 digits. So there are 11 numbers there. And we want to find the probability of n being prime. So in this list, we're going to look for the prime numbers. So there's 1, 2, 3, 4. So the probability of n being prime given that it has 2 digits is 4 out of 11. Okay, find the probability of drawing the given cards from a standard deck of 52 cards with replacement and without replacement. So with replacement means we're going to put the card back into the deck. So first we want to pick a club and then a spade. So of the 52 cards, there are 13 that are clubs. And then for the second card, we want to pick a spade. But we put the card back. So there's still 52 cards in the deck, and there are 13 spades. So that would equal 1 over 16, which is 0.0625. Okay, for part B, this time we're not putting the card back after we pick it. So for the first time we do it, there are 52 cards and 13 of them are clubs. But this time we're not going to put the card back and we're going to assume that the first card was a club. So there are only 51 cards left in the deck, and of those 51 cards left, 13 would be spades. So that'll be 13 over 204, which is 0.0637. And number 10, a king, then a queen, then a jack. So the first time we do this, we're going to put the card back. So the probability of getting a king on the first one is 4, because there are 4 kings in a deck. Then we're going to put the card back, so there's still 52 cards in the deck. And then picking a queen would also be 4, because there are 4 queens in a deck. Then we're going to put the card back, so there's still 52 cards to pick from, and 4 of those would be jacks. And that'll be 0.000455. Okay, for part B, we're not going to put the card back. So the first time, there's still 52 cards and 4 of them are kings. The second time we draw, there are only 51 cards, and we're going to assume the first one was a king. So there are 4 queens left in the deck. And we're not going to put that card back either, so there's only 50 cards left. And we're going to assume the first one was a king, the second one was a queen. So of the 50 that are left, there are 4 jacks. And that'll be 0.000483.